Hi everyone and welcome to this Python course. Okay, now that we are familiar with the math library, let's explore some of the functions we can use on our floats and integers. Of course, being a mathematical library, we expect that these are the data types that we can apply the functions to. I've shown you the floor. We have the counterpart, which is the ceil, that will basically raise a number to the next nearest integer. For instance, 2.4 will be 3 in return. And if I put here, for example, 1.1, I'll go for 2, and we can even pass a really tiny number, for example 1.00001. This will always seal the number to the next available integer. In this case it's 2. Other mathematical concepts, the square root. We can also use or rely on this math library to use the square root. Remember that I'm now executing these functions because I've already ran the import math statement. If you are having any issue with the name error, just run the import math statement before running these functions. Okay, math square root of 9, it yields 3, square root of 16 yields 4. I can also pass, of course, floats. Square root of 10.5, it's this number right here. We also have logarithms. Math.log1 will yield 0. This is base e, I think. If you know logarithms and all that, don't need to worry about them that much right now. But if you know them, this is base e. We can also change the base by providing new arguments. How do I know that? Well, if I don't know, I'll go for help, mathlog, and I have here x and base, 2 arguments. Out of curiosity, let's see if this supports keyword assignments or keyword arguments. So math.log x equals to 10, base equals to 10. And unfortunately, log takes no keyword arguments, so we can't use this way that we've learned. We just use positional arguments. Okay, in this case, the positional arguments work, and the second argument is our base. A lot of functions support keyword assignments, as we'll see throughout the course, but these ones don't. Okay, another thing, important thing. So there's no concept of a logarithm of 0 that should yield an error when we are doing mathematical calculations. If I pass math.log 0, I'll have a math domain error. That means that still in these functions that we are working on, Python respects all mathematical rules that we know. Okay, that's the most important part. Another important point, we don't only access two functions in this math library. You can also access special numbers. For example, the Euler's number. I just have to call math.e. See that I'm not opening or closing parentheses. That means that this is not a function that I'm calling right here. It's an attribute from this library. So this is a new concept that we are also seeing. It's not that common that we do that with certain libraries because these attributes are normally tied to certain objects, as we will see. Even so, here in the math library, we do that for special cases. Math.e will return 2.7182, the Euler's number. Math.pi, I guess you know what this will return, the pi number, of course, rounded to a certain amount of decimal places. Now, an important part, math.pi is not the same as pi. If I go for pi itself without the math dot, this is nothing for Python because the name pi in itself is not defined. If I want to use pi, I need to reference the math library because that's where the pi is stored, the number pi. Of course, I can also do this, like pi is equal to blah, blah, blah. Now, this pi is completely different from the math.pi. They are not the same thing, okay? And I can prove that by printing both. So, print pi, blah, 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 print math.pi, the number pi, okay? So they are different because they reference different places in memory. So the pi references the pi that I've just created, which is this string variable that has its binary string that's stored in my computer on my environment. The math.pi references the pi that's inside the math library that I'm referencing. So they are two different objects in memory, okay? Make sure you understand that. Although they seem the same, they are not, because one references the math dot, it references the library, the other does not. Okay. To close this lecture, let's see some trigonometric functions. Cosine, which we can use with math.cos, and math.sin for the sine the other trigonometric function that we can use here. We can also use tangents and all that, but I'm not going to go too deep into that as this is not a trigonometry course, so I'm going to skip those at least for now. Finally, before we move on to exercises, this was a bit of a shorter section because also there's not many things that we can do as transforming stuff when it comes to transforming stuff like we do on text here in these data types. The more important in this section was understanding the keyword arguments and also the library part, which was a way for me to introduce these concepts while we were studying data objects, and it's not too alien for you on how these concepts are introduced. Finally, before we leave, we have this concept, which is also kind of a number, but it's really not a number. It's literally not a number by the acronym. This NaN sometimes happens particularly if you're working with data analysis, this will not be alien to you. Just know that this is a concept that Python has for something that's not a number. As for instance, if you work with databases and you have the null value in those databases, this is kind of the same thing, numerical columns, okay? So represents the same thing of not having anything at all, of some kind of emptiness. Just know that this is available in this math library. Okay, we're done with these mathematical methods that we've applied here. Next, exercises, and of course, more about our RPG game that we are developing. Let's do them. And after that, we are going to go for our first data structure, which is also a way for us to commonly call more advanced objects here in Python. The list. The list is a super flexible type of object. It will be the first more advanced one that we will deal with, and I hope you're pretty excited about it. I hope you are enjoying the course, and I'll see you in the next lecture.